Welcome to Cheenta School of Statistics and Data Science. Today we are going to solve question number 53 of GATE 2022 statistics paper. The problem says that suppose a random sample of size 3 is taken from a distribution with the given probability density function fx equal to 2x into indicator of 0 x lies between 0 to 1. Now if p is the probability that the largest observation, that is maximum of n xn, is greater than equal to twice the smallest sample observation, that is 2 into x order 1, then we have to find the value of p. so so here the CDF of x is given by 0 when x less than equal to 0, and integration to 0 to x 2t dt for when x lies between 0 to 1, because the main part of the PDF is 0 to 1. Yeah. And 1 when x greater than equal to 1. So it becomes 0 when x less than equal to 0, x squared when 0 less than x less than 1, and 1 when x greater than equal to 1. Now the joint distribution of x order r and x order s is given by this when r is less than equal to s. This is important. So the joint density is n factorial by r minus 1 factorial into s minus r minus 1 factorial into n minus s factorial into fx whole to the power r minus 1 into small fx into fy capital Fy minus capital Fx whole to the power s minus r minus 1 into small fy into 1 minus capital Fy of whole to the power n minus s if x less than y. You can derive it from the following notion that the joint density is like this. So from the joint CDF, you can take the derivative in a small region. Say this is x, this is y. So this is x plus h, this is y plus k. Now we have to find this region and the beam corresponding to it. We'll get a region here. This will corresponding the density. So calculating the probability in the density, we will get the record PDF. You can check it. So here r equal to 1 because x order r is x order 1 and s equal to n, as we are considering minimum and maximum here. So joint PDF of x order n and x order 1 is given by n into n plus n minus 1 into 2x into y square minus x square whole to the power n minus 2 into 2y. We can get from this. Here fx equal to x square and if small fx is x. Provided x is less than y, 0 otherwise. So this becomes 424 into xy into y square minus x square into indicator of x less than y. Also note that here n equal to 3. The sample is of size 3. So the record probability is probability x order n is greater than equal to 2 into x order 1. So the probabilities can be given by the double integral in the PDF in the given range, that is x less than y and 2x less than equal to y. So you can draw the graph. The region is lying between 0 to 1. X, this is x, this is y. So x lies between 0 to 1 and y also lies between 0 to 1. So the line is 2x equal to y and x equal to y. We got considering x less than y. So this region comes and 2x less than equal to y, this region comes. You can hold a point here and check whether this is satisfying the condition or not. Now the record region is coming out to be this part. Hence the x lies between 0 to y by 2. This is it, 0 to y by 2. This is the line x equal to y by 2. So x lies between 0 to y by 2 and y is from 0 to 1. So integrating the PDF in the range, check the calculation here and get 0 to 1, 24 into y, what is your 4 by 8 minus what is your 4 by 64 dy. Integrating with respect to x. Now again in integrating with respect to y in the given range of 0 to 1, we get this is 24 by 64 into 7y to the power 5 dy 0 to 1 integration. This is coming out to be 7 by 16, that is 0.438 after rounding off to 3 decimal place. So hence the value of P round off to 3 decimal places is 0.438. Now the objective of the problem is to find the joint distribution of two order statistics, x order r and x order s, provided r is less than s. So you can find it by the checking the density, the CDF from deriving the CDF. So you can do it by so density is basically x order r, x order s, x y. This is limit h tends to 0 plus, limit k tends to 0 plus. This is basically actually the derivative with respect to x and y of the joint CDF. Okay, so by this we get taking the limits h tends to 0 plus, limit x tends to 0 plus, joint probability, that is x order r lies between 0 x to x plus h, and x order s lies between y to y plus h, y to y plus k, divided by the area h into k. So this is becoming that the hk is that area hk, and this is the probability, the density part. So we can fixed a constant, that is putting h equal to 0 outside and take the limit with respect to k, then we will get the joint density with respect to x and y. So here it becomes a line, that is here x plus h, and here is y plus k. Here lies between x order r, here lies between x order s. So there are r minus 1 values here. This is 1 value. This there are s minus r minus 1 values here. There is 1 value, and the remaining n minus s values are here. So we can arrange it. We can arrange it and get the required density. What we get in factorial by r minus 1 factorial into s minus r factorial into n minus s factorial for this kind of permutations, restricted permutations, and the values of CDF here. Here fx, here is small fx. This will be, after taking the limit, this will go inside with the small fx. This is fy minus fx. This part is small fy, and this will correspond to 1 minus capital Fy. So you can get that density from this also. So that is all for today. Thank you for watching. I will see you in the next video. Till then, stay tuned and stay blessed.